This is Unit 5, Review Problem 6. So it's about surgery and germs. So we have this guy Lister who, it must have been years ago, because disinfectants are pretty common these days, but he was doing an experiment, at least an attempted experiment, where he was using carbolic acid. He took 40 people and he used a treatment. He used carbolic acid as a disinfectant, and then with some other people that he had, where he had to do an amputation, he did not. He used nothing. Okay, and then he measured or recorded measured the survival rate. Okay, now there's a question about random assignment. They didn't really say. And that's one of our conditions that we need to have satisfied. So we're going to have to assume some things. Okay, so that's kind of what's going on, and I think that we have some data. The sample size for those that did have carbolic acid used as a disinfectant was 40, and X was C was 34. So P hat of C is 0.85, and then N of N was 35, and X of N was 19, and P hat of N, I'm going to have to calculate that. It's 0.543, and I'm just going to, just for myself, I'm going to say, I go -1. So just so I have Q hat handy if I need it, it's going to be 0.457. Not sure if I need it, but there it is. Okay, so the question is, what do we want to prove? What's our objective? So let's think through this before we do the hypotheses. So the question of interest is whether the carbolic acid is effective. Okay, so if we have, if the proportion, we want to show that the proportion of people that had amputations and carbolic acid was used, that their survival rate was greater than when it was not used. Okay, so this is what we want to show. We want to prove that. Okay, so our alternative would be that P subscript C minus P subscript N is equal to 0. Okay, and then our alternative is that P of C minus P subscript N is greater than 0, that the survival rate is higher. Okay, so we would write something like the survival rate when carbolic acid is used as a disinfectant is the same as when it is not used. Something like that. And so now we sort of repeat it with some changes. The survival rate carbolic acid is used as a disinfectant is greater than when nothing is used. And maybe I should have said here as when, maybe I should say as when, to be more precise, nothing is used as a disinfectant. Okay, so those are the hypotheses. So now to speed up this video a little bit, I'm going to just pull in the author's condition check. So let's do that again. So the random condition, there's no mention, I mentioned that already, no pun intended, but there's no mention of random assignment, so that's a little disconcerting. Okay, so we're going to have to, in order to proceed, assume that the two groups of patients were similar and that amputations took place under similar conditions. So there was only one variable. So this is required for an experiment. Just remember that. Okay, 10% condition is pretty easy to justify. 40 and 35 should be less than all possible amputations. So the independent assumptions, reasonable to think that the groups were not related in any way. I don't know for sure if I completely agree, because I don't know that. I could do some research though and find this out. But if these were people just came off of a battle scene, maybe their wounds were similar in some way that made them not independent. But I think in general, people's body chemistry and how they get infections are different. So anyway, we're going to have to live with this assumption for now. That's the best we can do. Now when we start doing the computations, let's see, P, or like NC times P hat, because we're doing two proportion test, that's going to be 40, right? 40 times 0.85. So we already know that that's 34. So we also know that NC times Q hat is 6. Okay, so this is greater than 10, but this 6 is not greater than 10. So we have a bit of a problem. And if we do N times P hat N, we already know that that's 19. So 19 out of 35. And then N times Q hat N, that's going to be, let's go up here, Q hat 0.475, so 35 times 0.475, or you could just do 35 minus 19. So what are we going to get? 6, 2, 1, so 16. There it is. All right, so we have a problem. So this is greater than 10, and this is greater than 10. So we have a problem. But remember that what we're doing is we're making an assumption. The null hypothesis implies a model, okay, that has a center at, in this case, the difference, C minus Pn equals 0. And then there's an implied standard deviation, SD of P hat C minus P hat n. So these are all things that because we're assuming the null is true, then this is true, which means this is true, which also means that if both populations are the same, okay, if they're both the same, then the two samples came from the same population. Okay, so what we can do is we can pool. So we get, let's see, what do we get? We get 34 successes and 19 successes out of 40 and 35. So that's going to be 53 out of 75, which is 0.707. So what we can do now is we can check this condition one more time. We can say, how about this? Times Q hat pulled. How will that work? So this is going to be 40, and Q hat pulled would be 0.293, and they do it right above, but I just want to do it myself. 40 times 0.293, I get 11.72. Okay, which is just barely big enough. That's just barely greater than 10. Okay, so we can argue theoretically that under the assumption that the null hypothesis is true, then the sampling that we did is consistent with using a normal model. Okay, so since the conditions are satisfied, we will perform a 2-proportion z-test. We will model the sampling the sampling distribution of the difference in proportions or proportion with a normal model. With a mean of 0 and a standard error of, okay, now our standard error for our model is going to be this, that's a C, P hat N. What do we expect of the difference? So that's going to be the square root of, and we're going to use P hat pooled. So what was it, 0.07? So 707 times 0.293, all divided by 40, plus 0.707 times 0.293, all divided by 35. So the square root of this entire thing, and you should be able to do this on your calculator. Don't use parentheses. Just say square root of 0.707 times 0.293 divided by 40 plus 0.707 times 0.293 divided by 35, close parentheses then, and then just hit enter. Okay, and you should get 0.1054. Okay, so now we have a model. With a center of 0 and a standard deviation of this. And so now the question is, we want to compare our observed value. Observed difference. Let's call it. So that would be P hat N minus P hat, no, I did that wrong, P hat C using the acid minus P hat N. Okay, and that's going to be what? What were those proportions? Let's go back up and look. Okay, 0.85 minus, what's 19? Okay, here, I'm going to do it this way. 34, so it's 34 out of 40 minus 19 out of 35. Okay, so that's going to be, you can do that in one entry. 34 divided by 40 minus 19 divided by 35. So I get 0.3071. That's the observed difference. So now let's see. I'm not quite sure yet. It's probably just easier. I could do the math and label the formula, but it's just easier to go straight to Z. Let's just see how far away that is in standard deviation. So we would do, what we want is we want the observed value minus the expected divided by the standard deviation of the model, and here we have to use the standard error. Okay, so that's the observed value, is the observed difference is 0.3071 minus the expected value was just 0 divided by 0.1054, and that's going to be 2.91. So if I go over here, 1, 2, 3, 1, 2, 3, like that, then it's going to be, wow, way over here. So P hat, well, I should just say the observed value, observed difference, OD, is equal to 0.3071, and Z is 2.91. Okay, so now the question is, what's the p-value? So we can already guess that it's probably going to be small. So the p-value is equal to the probability that the difference, the observed difference, P hat C minus P hat N, is equal to 0.30, no, is greater than 0.3071. So that's the probability that Z is greater than 2.91, and that's normal CDF of 2.91 out to infinity. Okay, and I get 0.0018. Okay, so don't mess around. Since the p-value is small, we reject the null hypotheses. Okay, there is strong evidence that the survival rate, I'm going fast, sorry about that, but you know how to spell. The survival rate is higher when carbolic acid is used to disinfect the operating room than when nothing is used. Okay, so there was a follow-on question. C, what concerns do you have? I don't quite remember the whole question. Let's see. Oh, what reservations do you have about this design? Well, that was our kind of, we had to assume that this was a random, there was random assignment. So we don't know whether or not the patients were randomly assigned to treatments. And we don't know whether or not blinding was used. So just say some concerns about the experiment design. In particular, random assignment. And blinding. Okay, so long video, but I hope that helps for those that need it.